This one is a slightly tricky question. You have to be very careful here. It says the sets Pn are defined as n plus 1, n plus 2, n plus 3, n plus 4, n plus 5 up to n plus 8. So there are how many numbers? Count it carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers are there, where n is equal to 1, 2, 3 up to 200 and 520. How many of these sets contain a multiple of 17? So first you need to understand the question, what exactly it means. If I take the first set, say P1 is equal to, if you want to find P1, it is put n equal to 1. So it is 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is P1. If you want to find P2, it will start from 2, 3 and it will go up to 9, 10, right? Put n equal to 2. If you want to find P3, it will start from 3. Now you can see it starts from 1, goes to 9, so plus 8. 2 plus 8, 10. So 3 plus 8, 11. In each of these sets, there are 9 numbers. Don't forget, it is each of them contains 9 numbers. Each of them contains 9 numbers. Each of them contains 9 numbers, right? So that way, P1, P2, P3, that way you continue up to 500, P520. So P520 will be, starts from 520 and the last number, the 9th number would be 528. Don't get, you can see that 520 to 28. So there will be 9 numbers. Okay, so this is just the definition of this set. What exactly is the question? The question is how many of these sets, so these are 520 sets. Out of these 520 sets, how many of them contain a multiple of 17? You see, when will a number be a multiple of 17? If I am talking about continuous numbers, then every 17th number is going to be a multiple of 17. So the first time a multiple of 17 will appear, I think here in the end. Do you realize, I just changed the color, so 9, 10, 11, 12, 13, 14, 15, 16, 17. So there will be a situation here wherein the last number will be 17, the previous number 16, previous number 15. Though I could have directly calculated 17 minus 8, that is 9. But just to check, 17, 16, 15, 14, 13, 12, 11, 10. We just need to check that in every set there should be 9 numbers. So count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the first number is 9, so it is actually P9. So the first time a multiple of 17 will appear will be the 9th one, P9. After that, a lot of them will contain a multiple of 17. Just to show, the way we have P9, similarly P10. Do you understand? P10, the first number will be 10 and the last number would be 18. So it will definitely contain a multiple of 17, right? P11, first number 11, last number 19. So somewhere there will be a multiple of 17. P12, the first number will be 12, last number will be 20. So somewhere in the middle, there is going to be a multiple of 17, right? And like this, P17 will have the first number 17 and the last number 25. Okay. So you see, from P1 to P17, how many sets are there in which a multiple of 7 appears? Listen very carefully what I want you to identify. Out of first 17 sets. Now, the next set, what will happen? Just do it on your own. In the next set, P18 will start from 18 and will end at 26. Start from 18, end at 26, right? P19 will start from 19, will end at 27. So what is happening? In P18, P19, P20 and so on, there will be no multiple of 17. Then when will the next multiple of 17 will come? The 9th term after this, right? So there will be P26. Just to show, P26, the first number will be, we need 34. Yeah, correct. So P26 will be the next number. Anyways, what I'm trying to explain is, because we have to count the multiple of 17, we have done up to the first 17 sets, and we see that out of first 17 sets, how many are there? There are from P9 to P17. How many are these? Count it carefully. From P9 to P17, count it on your finger very simply. P9, P10, P11, P12, P13, P14, 15, 16, 17. How many are there? 9 sets are there. Okay, we could have directly counted 17 minus 8, that is 9 sets. And that is going to continue in every set, in every group of 17 sets. I repeat, listen carefully. Out of continuous 17 sets, 9 of them are going to contain multiple of 17. So first 17 sets, 9 are there. Again next 17 sets, 9 are there. Again next 17 sets, 9 are there, and so on. So for example, out of first 170 sets, 90 sets are going to be there which have a multiple of 17. Out of 340 sets, there will be 180 sets. So basically just like that you can continue. But we have to check 520 sets. How do we do that? Now, below 520, the last multiple of 17 is 510. Wow. So why I'm taking multiple of 17? Because then the counting will be easier. Okay. So up to first 510 sets. Okay, let me clarify that further, though we don't need to write it in the exam, but just to hear, to understand. From P1 to P510. Answer 510. 510 is a multiple of 51, which is a multiple of 17. That is the highest multiple of 17 below 520. So out of these sets, how many are there which are going to contain multiple of 17? 9 out of every 17. So multiply by 510, and this will give us 3 into 9, that is 270 sets. Hold on, this is not the answer. So there are 270 sets up to P510 which are going to contain a multiple of 17, right? So we have checked up to 510 sets, but we need to check up to 520 sets. So after 510 sets, again the same cycle will start, in which the first 8 will not have any multiple of 17. The 9th member will have a multiple of 17. So what should I do? So till now, you can just pause and note down everything that is there. I'm going to need the space. So up to P510, we already have 270 sets. After that, P511 to P518, there will be no multiple of 17 in that. The 9th member, P519, will have a multiple of 17. P520 will also have a multiple of 17. So 2 more sets, right? Remember, I'll just to recall, in every set, in every group of 17 sets, first 8 don't have a multiple of 17, right? And the next 9, each of them have a multiple of 17, right? So first 8 will not have a multiple of 17, P519 will have a multiple of 17, and P520 will have a multiple of 17. So 2 more sets. So final answer of the question would be 270 plus 2, and that is 272 sets, right? So don't make this question a rocket science. It's a very basic finger counting question. Answer to this question is 272. You will have to type 272.